Welcome to the Polytechnic University of the Philippines, the country's first Polytechnic U. PUP is a state-run university governed by Republic Act 8292, known as the Higher Education Modernization Act of 1997, and its implementing rules and regulations contained in the Commission on Higher Education Memorandum Circular No. 4, Series of 1997. It is home to more than 70,000 students, making it the largest state university in the Philippines in terms of student population. It is the university's commitment to give qualified and talented students access to quality and responsive education to aid them in the achievement of their dreams and the improvement of their lives. True to its commitment of making education accessible to all, the university has strategically established campuses and branches all over Luzon. And 483 full-time and part-time faculty members and 707 administrative employees. The faculty and employees perform the collective goal of training, servicing, and supporting the university's stakeholders. From its humble beginnings in 1904, PUP was originally established as the Manila Business School, primarily for the training of personnel for government service and to provide skills needed for private employment. 4 years later, the Manila Business School was renamed Philippine School of Commerce or PSC and merged with the Philippine Normal School from 1933 to 1946. Through the virtue of Republic Act 778, PSC was renamed to Philippine College of Commerce or PCC in 1952. In April 1, 1978, PCC was converted into a chartered state university now known as the Polytechnic University of the Philippines by virtue of Presidential Decree No. 1341 issued by the President of the Republic of the Philippines. PUP truly has come a long way from a business school to a premier polytechnic university, the very first in the country. Every year, around 50,000 graduating high school students, mostly from economically challenged families, take the Polytechnic University of the Philippines College Entrance Test or PUP set and hope to become one of the 10,000 who will be given a chance to be new PUPians. At present, the university offers more than 80 programs in the graduate and undergraduate levels with its strategic direction of making the colleges vertically articulated. Graduate School, College of Accountancy and Finance, College of Arts and Letters, College of Architecture and Fine Arts, College of Business Administration, College of Communication, College of Computer and Information Sciences, College of Education, College of Engineering, College of Law, College of Political Science and Public Administration, College of Social Sciences and Development, College of Science, College of Tourism, Hospitality and Transportation Management, College of Human Kinetics, Institute of Technology. PUP further strengthens its open university system through expanded tertiary education equivalency and accreditation program and the non-traditional system program. It caters to borderless educational system that aims to reach many learners as possible. For more than a century of existence, countless outstanding achievements have raised PUP to the level of a national comprehensive university. With the vision to transform the university into an epistemic community, PUP subscribes to the idea that a university should have an extensive research and extension development culture. Proof to this are numerous research undertakings of the university. Each year, PUP surpasses national passing rate in licensure examinations and ranks among the top in different academic disciplines. Has also institutionalized academic exchange and international cooperation with various countries all over the world through its Office of International Affairs. Today, PUP is relishing its successes, and its students are enjoying unprecedented academic opportunities, an enhanced campus environment, upgraded colleges, state-of-the-art technology, and nationally and internationally recognized programs. It has gone far from what it was more than a century ago. This is mainly due to the support given by the government, the PUP community, and its benefactors. With the combined efforts, PUP will continue to be a partner in nation building and in poverty alleviation for the marginalized sector of the society with quality, responsive, and relevant education as a tool. PUP, the country's first polytechnic youth.
Allow me to share with you my vision for the university. I envision PUP to become the pioneering and leading national polytechnic university in the 21st century. With a national polytechnic university status, it will bring more opportunities for the university to further strengthen its academic programs and improve organizational performance as an institution for higher education. In pursuit for this vision, my mission for PUP is for it to recognize its catalytic role for national development. PUP will ensure inclusive and equitable quality education and promote lifelong learning opportunities through a re-engineered polytechnic education. By re-engineering, we look into the existing processes and programs in order to achieve higher quality of academic programs and services following the principles of effectiveness and efficiency. With this mission in mind, I have formulated 10 pillars as my reform agenda for the university. Pillar 1. Dynamic, transformational, and responsible leadership. Empower academic and administrative leaders by following the core principles of good governance to create collective growth and unity. Here I would like to highlight an innovation by introducing the development of an integrity management plan to assess, plan, and implement anti-corruption strategies that will secure the institution against corruption and abuse. Likewise, asset management and resource generation will be aggressively pursued to ensure productivity and finance the implementation of the plans and projects for the university. Pillar 2. Responsive and innovative curricula and instruction. We aim to provide world-class polytechnic education that responds to national and global needs by developing intellectually challenging curricula and design academic programs that are based on industry demands to provide the learners with adequate and relevant competencies and skills and prepare them for a successful and rewarding careers. In a rapidly changing world, we recognize the paradigm shift in curriculum to outcome-based education with lifelong learning approach. Pillar 2 also sits on the framework of internationalization of Philippine higher education through transnational education by promoting academic mobility among faculty and students and global dimension into the curricula and teaching process. Pillar 3. Enabling and productive learning environment. Following education in Industry 4.0, we aim to increase and enhance the use of new technology to enable student learning and engagement, as well as advanced teaching process and methodology through new and state-of-the-art facilities that will support the overall learning and teaching experience in the university. Pillar 3 likewise includes campus development and the provision of conducive learning centers and facilities for students and faculty. Pillar 4. Holistic student development and engagement. We will empower students as well as rounded learners and active young leaders as we open opportunities for various academic mobility and venues for honing skills and personal development, being the principal stakeholder of the university. Recognize academic freedom as a form of self-expression and a platform to showcase students' intellect, skills, and creativity. Pillar 5. Empowered faculty members and employees. Likewise, we are looking into the holistic development of our faculty and employees as productive, competent, and experts in their respective fields. We will encourage our faculty roster through formal education, capacity building, research and extension initiatives, faculty immersion, and other academic engagements, both local and abroad. We will ensure that both our faculty and employees will have a vibrant career development path as public servants in this state university. Pillar 6. Vigorous research production and utilization. We will continue to strengthen the research culture in the university by promoting discovery and innovation through increasing disciplinary and collaborative research integration across academic disciplines to create new knowledge, utilize research findings, and develop innovative products. Pillar 7. Global academic standards and excellence. Achieve the highest levels of recognition in quality and compliance standards from CHED, AACUP, and other international accrediting and regulatory bodies for higher education. We will intensify our efforts to achieve and sustain better academic performance and continue to excel as a top-performing school in various professional licensure examinations and produce board top-notchers, as well as sustain our status of being the most preferred graduates of employers. Likewise, we aim to establish and to be recognized as centers of development and excellence in our academic programs. Pillar 8. Synergistic, productive, strategic networks and partnerships. Synergize and forge strategic linkages and partnerships across all sectors of society and the global community in line with the overall plans and programs of the university. Establish alliance with the government, industry sector, NGOs, and the academe will lead to resource sharing, program support, and research collaborations beneficial for all. Pillar 9. Active and sustained stakeholders engagement. Harness a healthy and harmonious organization by empowering all its stakeholders, both internal and external, through open communication networks, consultative and participative undertakings, and team-building activities, recognizing that all stakeholders can greatly contribute towards the betterment of the university. Pillar 10. Sustainable social development programs and projects. Expand access to education, knowledge building, and information dissemination through sharing of expertise and resources for community development. Support inclusivity approach and education by embarking on Education on Wheels, which aims to bring access to education closer to communities, following the principle of no one will be left behind. As the University of the People, we should bring the university closer to their hearts to serve their needs and extend assistance in mainstreaming public service. Our institution must continue to stand as one for the values that we have inculcated. For the past 115 years, we have exemplified our quest for truth, excellence, equity, relevance, effectiveness, integrity, and academic freedom. Lastly, I call upon each and everyone to join me in this journey. Together we stand as one para sa sintang paaralan para sa ating bayan.
Tao, lugar, pangyayari, bagay, ginagamit ko. Yes. Sa classroom. Yes. Sa classroom. Sinusulatan. Papel. Manila paper. Blackboard.
Welcome back, schoolmates!
Maligayang pagbabalik sa muling pagsisimula ng klase.
Kasabay ng pagbabalik ng eskwela ay nagbabalik din ang inyong online tambayan dito sa Pamantasan. Ako si Erin.
At maghahatid ka naman ng everything you have to know. Ako si Yel.
Tampok ang mga nakaka-proud at huwarang PUP at naman si Sir Dennis.
At muli nyo kaming makakasama sa Back to School episode ng Pinakausap-usapan sa Pamantasan!
Nagtapos ng Bachelor of Science in Accountancy taong 2018, magna cum laude. I ranked 5th in the recent CPA licensure examination. Wanting to become a CPA is my own personal choice. Nobody pushed me to lead this path but myself, and now I'm glad I made it. After the exam, I have no expectation to rank the board, but I'm sure I'll pass, hoping that the ones I'm not sure about will be correct. I felt very fulfilled and happy knowing that all my hard work paid off. Apat kami magkakapatid, 3 kaming sabay-sabay na nag-college, yung 2 private. Ako naisip ko na kailangan kong tulungan yung mga magulang ko para mabawasan yung gastos. Ang tanging choice ko ay mag-aral sa PUP. Kaya kung hindi dahil sa PUP, hindi ako nakapagtapos. Hindi ako magiging isang ganap na CPA at lalong hindi ako magtatap sa board. During my first year and second year in this accountancy, I see to it that I studied 8 to 9 hours a day and increase it to 12 hours a day during exam weeks. I cut out something that doesn't help me, such as TV, K-dramas, doubts and anxieties, and thus is never my goal. My message to aspiring CPAs is to never give up, study hard because there is no other choice, and make no excuses. Minsan akala natin malayo pa, hawak kamay na natin pala. And yes, it really takes commitment of daily practice on yourself. I'm still in the process of choosing my career options. I'm still praying to God that I'll arrive at the best decision for me. CPA, claim, pray, and action. Claim, kasi if you can envision it, you can bring it into your reality. The first thing to do before anything else is to pray. For action, because nothing will change if you don't work for your dreams. Ako si Aren Gavino, ang most outstanding JPM in academics in NCR, batch 2018, magna cum laude batch 2018, ng Bachelor of Science in Accountancy, at top 5 ng May 2019 CPA licensure examination, katak PUP.
Isang masigabong palakpakan para sa mga
Yes!
mula sa Sintang Paaralan.
Correct ka dyan, Ma'am Yel. At talagang ipinagmamalaki namin kayo, no, mga schoolmates. And
Tama.
by the way, para naman sa mga hindi pinalad na makapasa, ay do not lose hope. Sabi nga nila, try and try until you succeed.
Joke na.
Yan, tama po yan, sir, no? At isa rin po yung pagkakataon para sa aming mga scholar ng bayan
Yes.
upang matuto at mapapalapit sa
Yes.
aming mga pangarap. Yan, di ba? Ito po ba?
Meron ka dito. Itong
Balik
batang...
na tapos na tayo.
Ito nga,
Sige
may
po,
kasi
ma'am,
ka pala.
sige.
Anyway, sige, itong online tang bayan, di ba?
Yes,
Tama,
sir.
at para maging updated din ako sa usawa sa
PUP Creative sa Facebook at i-like ang aming page.
Yes.
At
Note, kita-kits mga schoolmates hanggang sa susunod nating mga pag-uusap dito sa inyong paboritong online. Sa Laguna, oo. Hindi, pwede. Oo, pwede.
ilalabas ko.
Ako si Aren Gavino.
dati, may tayo pa pero ngayon, kayo na.
Praise God from Noon pa man, malaki na ang naging bahagi ng mga kababaihan sa lipunang Pilipino. Kaisa sila sa marubdob na paghahangad ng kalayaan ng ating lahi. Kabilang sila sa paglinang ng ating makulay na sining at mayamang kultura. Kasapi sila sa pagtataguyod ng mga adhikain ng kapwa mamamayan at sa pagtugon sa mga pangangailangan ng lipunan. Katuwang sila sa pagtuklas sa mga larangan ng agham at medisina. Kapanalig sila sa pagpapairal ng batas, karapatan at katarungan para sa lahat. Kabahagi sila sa paglilingkod sa bayan at sa pagpapanatili ng demokrasyang Pilipino. Sa paglipas ng panahon, hindi nagmaliw ang kanilang pag-ibig sa ating inang bayan. Mga kababayan, ito ang alay ng mga kababaihang Pilipino para sa bayan. Tumayo po tayong lahat at sabay-sabay nating awitin ang pambansang awit ng Pilipinas.
Kayang magiliw, pero sa silanganan, alam ng puso, sa dilim mo'y buhay. Lupang hiniram, dulatan ng pag-ibig, sa manlulupin, di ka masisingil. Sa nagatak lulok, sa silang at sa langit mong bahag, may ginanang tula at awit sa paglayang minamahal. Ang isang ng patawad mo'y tagumpay na naglilingin. Tuwing nag-araw na kailan pa malimating, lumalang araw ng walhati pagsika, buhay ay langit sa piling mo. Ang higaya ng pag-ay makakamit, ang mamatay ng dahil sa'yo.
Hi, I'm Engineer Florinda H. Oquindo, Director of the Alumni Relations and Career Development Office. The role of our office is to keep connections among students and alumni, provides complete range of services to students, alumni, and employers in the area of career development, graduates and professional schools preparations, employee relations, and campus recruitment. We also provide alumni and students with the tools and resources to help find success in all professional endeavors. To all freshmen, please come and visit us. Our office is located at N209 North Wing 2nd floor.
Okay, isang magandang umaga para sa ating lahat, para sa ating mga viewers sa PUP Alumni Facebook page. Good morning para po sa ating mga attendees via Zoom. Maraming salamat in gracing your time and effort in attending this alumni webinar. So, without any further ado po, start po natin kasi kanina medyo Sir Luzon. So, our speaker is from Sydney, Australia, Miss Engineer Dennis Luzon. So, sir, discuss ko lang po saglit ang ating webinar etiquette. Okay. So we do have 2 participants for this event. By the way, I'm Professor Jane S. Pulma of the Alumni Relation and Career Development Office. And this is our PIP run for this alumni webinar. So for our Zoom participants, please remember to keep your microphone always on mute. And remember that we are currently on live stream. So kindly raise your hands during the question and answer portion, so we can unmute you, and you can also raise your question via our Zoom chat, and all questions will be entertained during the Q&A. For our stream participants, welcome at maraming salamat sa pag-attend sa alumni webinar under the College of Engineering. You may use your comment section for your question. Kindly introduce yourself with your course, name or college and section, and we will be monitoring and including all of your questions during this webinar. So for everyone, we'll be sending the evaluation form on your email after the webinar, and we'll be posting or flashing the alumni, the evaluation sheet or evaluation form or evaluation link at the Zoom chat or the comment section of the Facebook page. The digital certificate will be available 2 to 3 weeks after the conduct to those who attended, participated, and accomplished the evaluation form given at the end of the session. So just make sure that to accomplish the form, because it will be only accessible 6 hours after the webinar. So guys, medyo pasensya na rin, kaya medyo intermittent po ang connection natin. Sir, pasensya na Sir Denise. Alam kong medyo maganda po ang signal ng Australia. So compare sa Pilipinas. So pasensya na po kung ang internet natin is medyo naglolo ko siya ngayon. Okay? So guys, before we start, let me play the message of the President of the Polytechnic University of the Philippines, Engineer Manuel Muhi, for this event.
A pleasant day to everyone. To our executive officials, Dr. Seni Sarmiento, Vice President for Student Services, Deans and Directors, Professor Floro Quindo, Assistant Vice President, to our guest speakers, and most importantly, to our beloved students. Thank you for joining the BALIK SINTANG PAARALAN webinar series. Thank you to ARCDO for organizing and hosting this event, which provides a great opportunity for the university to continue to engage with our alumni. Our alumni as stakeholders will always play a role in fostering a culture of excellence at our university. Their voices are invaluable in pointing us in the right direction, being key contributors to their respective industries, and we recognize their role as our university's ambassadors. I believe that our alumni are always eager to give back to their alma mater, and this webinar series provides an excellent opportunity for them to do so. Thank you to all of our alumni guest speakers for taking the time to mentor your fellow scholar ng bayan. Your many stories of tribulations and triumphs will undoubtedly inspire our students who want to follow your footsteps and use education to achieve success. Your presence here today sends a message of hope to all PUPians that despite many limitations, it is possible to rise and that success is within the reach with hard work, discipline, and drive. To all of our student participants, a pleasant day to everyone. To our audience, that despite many limitations, it is possible to rise and that success is within the reach with hard work, discipline, and drive. To all of our student participants,
Okay guys, pasensya na, medyo naglalag po. So shout out tayo sa lahat ng attendees natin from the College of Engineering. Our attendees coming from outside, meron po tayong attendees from the NTC. We also do have not just engineering, we also do have from College of Education and some other colleges. So this alumni webinar is created, or it aims to create a dynamic relationship between the alumni and the university that will stimulate the interest and build loyalty and increase her or his engagement with the university. So it encouraged the graduates to actively participate and volunteer in our community event, as well as it also aimed to broaden the network of community locally and globally and sustain the lifelong learning of the university. So this webinar would like to inspire the student body in sharing the wonderful stories of our alumni, their stories of success, their stories of determination, their stories of their passion. So this is our way to motivate not just the student currently working on their degree, not just in engineering, but currently working and pursuing her lifelong dream. So without any further ado, let me introduce our speaker for today. On mute. I'm not on mute. Hello? Okay. So, pasensya na po, sir, kung medyo talagang nag-in and out ang ating connection ngayon. So, guys, pasensya na and please bear with us. So, in behalf of the Alumni Relation and Career Development Office, I would like to apologize po dito sa connection problem natin. So, as much as we want to be perfect on this kind of event, or not just to be perfect, to do our best on this event, medyo may mga bagay po na anticipated namin. Okay. So, to this, nawala ako. Our speaker for today is a graduate of batch 1997 from the College of Engineering, Bachelor of Science in Electronics and Communication Engineering, 20 years experience in integrated circuit layout design with proven track record in semiconductor industry. He started his career in 1997 after graduation in the Polytechnic University of the Philippines with a degree of BSECE as an IC layout engineer and ROMH MLIS LSI Design Philippines, gaining extensive experience in chip layout and floor plan and block level design. He also worked at Cochlear in the world leader of innovative solution in hearing loss treatment in Australia, and various activities for the ASIC team on 2 contractual occasions. He also do have a 3 years experience in Catena microchip microelectronic in Netherlands, involving in multiple wireless chips project, and then eventually in NXP, which was acquired in 2012. So he do have 7 years of experience in Selena Semiconductor based in Sydney, and lead the mark design and reticle layout preparation in final GDSII database submission to Foundry debate. To Foundry House. So without any further ado, let me introduce our speaker for today, Engineer Dennis Luzon from Australia. Good morning, Sir Dennis. Pasensya na po, medyo naglalag ang internet namin.
Oh, it's all good. Okay lang. Good morning everyone, or good afternoon from here in Sydney. Thank you for organizing this event. Especially doon sa ating mga sa ating PUP President, si Engineer Bong Muhi, and also to Engineer Florinda Oquindo for our alumni connections, and of course to Professor Jane, and also to the all the PUP College of Engineering professors and deans, and also for the for Engineer Ado, for the College of Engineering, Dean of College of Engineering. Good day po sa lahat. Okay po. So yes, our topic po for this for today is about the RFIC. So let me share my screen. Just one more thing po. Can you hear me loud and clear? Just want to make sure that everyone here po. Okay, well, let me share my screen for the presentation. Okay, so good morning everyone again. So our topic for this morning is the RFIC and mixed signal layout techniques. So I think back in 2018, 3 years ago, I presented as well the basics or the introduction to the College of Engineering. I think it's mostly students from ECE and computer engineering. So hindi ko alam ngayon kung sino yung ating audience. I think there are some students who are not into engineering background, but still you can still learn from the presentation po. Okay po? So RFIC mixed signal layout techniques. Okay. So let me do the how do you do the presentation? F5 review slide. Sorry, view. Slideshow. Notes, no reading, slide master. Just hold on a second po. Okay. Okay, so what are we going to learn for today po? So there are a few items here po. So one is the introductions to the IC layout, and the next one po is the background and history of ICs, or integrated circuits. Let me just do the presentation. How can you do the presentation? Sorry, yeah. Let me view slide, presentation view. There you go. Okay, so okay, so the background and history of IC, the chip design development flow, and the top 3 semiconductor foundries and EDA companies, and IC layout techniques. And this one is my my favorite, the open source MPW or the PDK. So this one po is open source. It means it's available and free to use for everyone. Okay po? And then there are 3 emerging technologies. What are the 3 emerging technologies in semiconductor, and some of the chip development that I design and co-design po. Okay po? Okay, so introduction. So what is integrated chip, our IC layout? So it has many names po, okay? So integrated circuits is also known as IC layout, mask layout, or mask design layout. So by definition po, it's a representation of integrated circuits in terms of planar geometric shapes. So as you can see here po on the side, there's an image of an IC, and this is drawn in all different geometric shapes. Okay po, that is why that's the definition of the IC mask layout. Next is do you know Moore's does anyone knows Moore's law po? So I think the engineering students knows this po. So Moore's law, is Moore's law dead? So that's a question. So I don't know if you can see the one on the left. That's the graph of the numbers of transistors on each chip starting from 1970 up to 2020. Okay, so Moore's law is the by definition po, it says the number of transistors in a microchips doubles every 2 years. So is Moore's law dead? So that's the question. So as you can see po here on the right side, there's a crop 2 of the Apple chips po. So the image is taken, or the source taken from Wikipedia. So you can see that there po online as well. So for Apple A13 Bionic chip and the Apple A15. So the A13 po, that was launched back in 2019. The number of transistors has 8.5 billion transistors. Okay pa? But the A15, which was launched just recently, I think couple of months from this year, it has a number of transistors somewhere around 15 billion. So 2019 to 2021, that's two years gap between them, and the number of transistors is almost doubled from the 2 generations of Apple. So I think there's still the Moore's law still applies to most of the semiconductors, but some of them, in some aspect, it's not applicable anymore. Okay po? So that's the Moore's law. So the number of transistors every year or every 2 years doubles. So it's really cool po, that law. Okay po? And the next slide po that we can see here is how chips are made. So I took some presentation po from Intel websites. This is how we can see in picture how they make the semiconductor or the chip. Okay, so from initial point, from the starting point po, it's the main product or the main element of the silicon is starting from sand. sand, and then they will heat it up for few or 10,000 or I don't know how many degrees Celsius. They heat it up, and then they melt, and then they just grab the silicon, the pure or 100% silicon components of that sand, and then they will create an ingot. An ingot is like, when, imagine, as you can see in the picture po, it's like so they put like a small rod, and then over time they will create like a barrel of a silicon, and it's like a big chunks of silicon po, okay. And then once they have that, they will dice it and cut it into small pieces and turn it into a wafer, just like this po, okay po. So it's really thin, just like this. And then the next step is photolithography. So it's just when it's like, imagine you have just a good example is when you want to print an image on your t-shirt, okay po? So you have a silk screen, and then you have a pattern on that screen, and then you put a squeegee and a paint, and then take it out, and then you have the print. So that's the same principle for the photolithography, but it's a more advanced, and it's smaller dimension, okay pa? Next is the ion implantation. So they implant ions, and then so it's more technical, but yes, it's like they bombard it with ions, and then once they have the ion implantation, they etch it away, so it's like washing all the excess of those ions, and then they generate or create the gates of the transistor. And then after that, number 7, they created the gate, or the what is the gate. And then after generating the gate, they have the metal deposition, so they deposit the metal or the interconnection of all the transistors po, okay. And then after that, they keep going until they finish the finished product of the chip. So once they create or print all the chips in the wafer, they cut it. So imagine if you have a pizza, you want to eat a pizza, before you eat it, you have to cut it or slice it. But the way pizza is sliced is or like a triangle shape. But for the silicon wafer, it's only 2 directions. It's either vertical or horizontal. And then once they have that, they pick one of the chip and then put it in the package. Okay, so that's how chips are made. And how chips works po. So the way chips work is a result of how a chip's transistors and gates are designed and the use of the chip. Okay, so a chip contains millions or billions of transistors that is interconnected to each other. And those transistors acts as a switch, and then prevents or allowing electrical current to flow. So of course it depends on the application po. So each chip has their own different applications. Okay pa? Okay, so the IC chip development flow. So what are the basic flow? These are just the really basic flow of developing an IC. Okay po? So number 1 po, as you can see here po, so highlighters, let me do laser pointers, okay? As you can see here po, specifications. So the first point of contact in developing a chip is you have to have a specification. You have a requirements, okay? So we want to design a certain chips, like what? Maybe a chips for 5G millimeter wave development, or 5G products, or a chip for making a power amplifiers, or a chip for design. You want to design a chip that that you can use for medical devices. Okay po? So those are the specifications. And then once you have all those specs, you're going to draw a schematic. Okay, so as you can see there po, I just draw a simple inverter schematic symbol. So these are the example of an schematic. So once you have a schematic, the designer or the circuit designer po will simulate to make sure the design is working. So if when the circuit simulation is not working, it goes back to the circuit design again and then reiterate, and then until the design simulation is good or working. Then once the circuit simulation is fine, and then goes the layout. Okay, so the layout is the physical part of the schematic. So as you can see here po, I draw a simple inverter layout. So you have the schematic here, you have the layout here. So layout is the physical representation. That's the print that we're going to put on the chip. Okay pa? So how do we check if the layout is good? So we have some process called layout verification. Okay, so you have to verify, you have to make sure that your layout is equivalent of your circuit design. So we have certain checks like layout versus schematic. So we have to make sure that the interconnection or the net list of the schematic and the net list of the layout are all the same. So once you get once you let's say you don't have a verified layout, it's not matched yet, so you have to go back to your layout, reiterate your design until you get it done. So once you're done, yes, I'm done, you could do the extraction, layout extraction. Okay, so there's another process. It's the same as or equivalent to the layout or the circuit simulation, but this one is on the layout part or on the physical part of this design. So once you're done, you go back to your schematic, you mix those two simulations. So you have the schematic extraction and you have the layout extraction. You have to compare those two, make sure those two are the same. So once everything is done, then you have to implement the design. Okay, so that's where we're going to have the wafer. Okay, but next is semiconductor market share. So this is just to give you an idea who are the big players in the industry. So as you can see here po, on the left side, we have a graph, and 28% of that that share is owned by TSMC. I hope everyone knows or someone knows what is a TSMC company. So TSMC is the Taiwan Semiconductor Manufacturing Corporation. So they are all based in Taiwan. So the headquarters are based in Taiwan. UMC is also a Taiwanese company. So as you can see, the top two are from Taiwan. And then maybe everyone knows what Samsung is. Samsung, they have different types of products. So they have white goods like fridges and TVs. Okay, and one of the department or the companies they're also doing is a semiconductor. So they also have a fabrication, and 10% of that share is owned by by Samsung. Samsung is a Korean company, a South Korean company. And then the third one, 7% of that is owned by Global Foundries. So Global Foundries is also an Asian company, but I think most of their fabs or fabrication house is based in Singapore. Okay, so Singapore is one of their big there are lots of fabrication house in Singapore. Okay, so as you can see here po, so I just picked those top 3 companies the TSMC, Samsung, and Global Foundries. Majority of that is owned by TSMC. Okay, so as I said po, foundries and EDA. So the top three foundries, just what we saw on the market share, TSMC, or the Taiwan Semiconductor Company. Second one is Samsung. It's based in South Korea. And Intel. Intel is based in the US. So the thing is, Intel is the only one who is not a pure play foundry. When we say pure play foundry, because Intel has their own fabrication house, they have their own manufacturing, but they only manufacture their own product, like their own CPUs, like those Intel processors and those Intel memories or Intel video cards. Okay, but I think there's a plan, and they have they're investing around 20 billion over the 3 years to become a competitors for TSMC or Samsung. So imagine just building one fabrication or one manufacturing plant for an advanced process. It will cost them like 10 billion just to make one fabrication house. Okay, po? And the top 3 EDA companies, or the electronic design automation companies. So Cadence is the main player. So EDAs, these are the software that the design house use. These are the top 3 companies. So if you work in, if you are going to have a chance to work in a high-tech company or design company who develops chips, you will hear or use Cadence. Okay, so Cadence is the number 1, Synopsys is the second one, and then Mentor is the third one. I think Mentor now is owned by Siemens. Okay, so if you know Siemens is a big company, and they buy smaller companies. So one of the companies that they bought recently is Mentor. So Mentor is now under the hood of Siemens. Okay, so now we go back to the basics. Okay, so basics of IC layout before we go to the advanced, because I think when we present this 3 years ago, I'm not sure if those students are still with us, but I'm pretty sure like Sir Jeff and Mom Myrna and Mom Noriega and Mom Ado, they were there during the presentation, and I present this as well. So we go back to the basics again. Okay, so basics of layout. So transistors is the main devices in a chip. So when we say transistors, there's 2 types of transistors. There's one that is an N-channel transistor, and the other one is a P-channel transistor. So on the left side, that is the schematic symbol, and on the right side is the layout equivalent of that devices. Okay, so as you can see here, so transistors are composed of 3 terminals at least. Okay, so those terminals are the drain, the gate, and the source. So as you can see here on the layout, we can see the equivalent of that. So the drain is this guy here, and the red, those are the gates. Those are the one that acts as a switch. It may be on, it may be off. Okay, and then the other terminal is the source. So those terminal, the source terminal normally connected, it connects to the power or ground connection. Okay, and there's another terminal here, they call it the bulk. Okay, it's just As you can see on the left side, we have the bulk symbol or the bulk representation here. So those are the compositions of each layout. Okay, so on the P channel, it's almost similar with the exemptions of one layer. As you can see, the broken line, the red broken line, those are the end well or the well. So to separate, so if you imagine, if you put those designs, the p-type transistors or the p-channel transistors and the n-channel transistors, if you don't separate them or distinguish them, this one is p-type and this one is n-type. If you don't put the two the differences and put them in the same wafer, it will create a shorts. That's why on the design they have as distinction. So the one with the broken line or the red broken line is the p-type and the other one is an n-type. Okay po? So hopefully everyone still follows po. Okay, so we're still a few more slides. Okay, so resistors and capacitors. So these are also one of the common devices used in semiconductor or the chip. So as you can see, just to make give you a clear understanding. So if you're on an engineering background, you can probably see or you can find a circuit or a resistor or a capacitor, you know, on your mobile phones or your cell phones or on your TVs behind. You can see all those discrete devices. Okay po? So sometimes you can see resistors, this big piece of resistor with different color codings. So those are the discrete resistors. Okay, so we use that to connect to the PCB. So imagine on a silicon or a chip level, those resistors, you don't see those big chunks of resistors anymore. You just see one, all of them together in the same silicon chip or wafer. Okay pa? So the resistor, that's a symbol here, and this is the equivalent of the layout on the right side. Okay, so there's two terminals. One is positive on the left and one is negative on the right. So you have two terminals. Same thing with the capacitors. So you have a plate capacitor. So these are the two metal plate capacitors as a basic example. So you can see there's a bottom plate and there's a top plate. So it looks like the same composition of resistor, but resistors only have one big red layers there, but the metal or the plate capacitors, they have two metal layers. Okay po, you can see there's one on the top plate which is smaller and one on the bottom plate which is wider or bigger. Okay po. Okay, so what are the transistor layer compositions? So as you can see here po, I put just to understand, for everyone's understanding po. So you can see we have the transistors here, we have the drain, gate, source, and the bulk contact. And if we put one by one, if we separate the layers one by one, okay po, you can see the green layer, those are the active layers. The red layer is the polysilicon or the gate. Okay, and see those small square in the middle, those are the contacts. Those are the one that connects the lower layer and the metal layer, or so if you can see here po, so the active layer is the green, and then we have the blue layer which is the metal layer, and then we have the small square which is the contact. So that particular layer there, it connects those two po. Okay, so then we have the n-type diffusion as well and the p-type diffusion. So the n-type diffusion is the one you use for an n-type, p-type, yeah, so the one that you use for a positive or a p-channel transistor. Okay pa? Pasensya na po if I'm getting too fast, just let me know or or message me or shout out, okay? And then, so as we go back there, there's a transistor layer composition, and this one now is the cross section, okay? So if you imagine po, if you cut this device, tiny devices, cut it in the middle of that chip or that specific device, you can see the cross section. So I think most engineers, especially maybe architecture, can understand what is this cross section means. So, or the civil engineers students, okay? So you can see if you cut them in the middle and see what's inside, you can see there's compositions of P substrate. This one here is an N plus device, and another N plus device, and then these are the bulk or contact, which is a P plus device. So as you can see, we have an N, P, N device. So this is an NMOS, sorry, this is an NMOS device, okay? So N is the drain, that's the negative part of the transistor, and then the source is also a negative part, or N, and then the wafer level, so as a P substrate, those are P type devices. So you can see, you can easily understand that this is an NPN device, so this is an NMOS device. Same thing po, so I don't have cross section for a PMOS, but it will be the other way around. So you can see this one will become P plus, and this one will become N plus, okay? Okay, so this one is the inverter cross section. So as you can see po dito sa left side, these are the schematic of the inverter, and this is the equivalent layout of the inverter. And then as the same thing, if we do the cross section, you can see the insides of that particular inverter, okay pa? Okay, so what are the layout techniques for transistors, okay, for contact? So as you can see here po, if you have a chance, or after your graduation as an engineer or engineering students from PUPs, it may be you are an electronics engineer po, or computer engineering students, or even sometimes even civil engineers, they can get a job as an IC layout engineer, okay po? So here, these are some pretty basic techniques on how can we make a good layout. So one on the right side po, as you can see, these are the transistors, okay? So one on the left side has a single contact. The one on the right side, it has a distributed contact. So the one on the left is a bad design, okay? And the one on the right is a good design. Why? Because we have to make sure that there's a good connection between the source of that device or the drain of that device. And if you have just one contacts here, sometimes in fabrication, they will not guarantee 100% that they can generate as a good contact. So if you only have one contact there, and then during the fabrication process that contact is not generated properly, then you're going to have a big problem on your chip, okay? Matching transistors, okay? So how do you match the transistors po? So on the layout aspect, so the one on the left side is bad and the one on the right side is good. Why? Because you have to make sure, if you want to match your transistors or your designs in your chip, it has to be on the same orientation, okay? So same direction of the transistors. So if If your poly or the gate, the red here, as you can see, and the one on the left is vertical and the one on the right is horizontal, then you're not going to get a good matching, especially during fabrications or manufacturing the chip. Okay, so that's why the one on the right side is the good approach or techniques in creating a good matching transistors. Okay, and also the current flows in the same direction. So this one, if the current flows on the left side, and then it goes on the right side, but the current flow on these devices, it goes from up then going down. So the current flow for these two transistors are not the same. It's a bad practice. Okay, pa? Okay, number 2, interdigitated devices. So as you can see here po, there is I draw two devices. One transistor is named A and the other transistor is named B. So each transistor po, for example, you have a number of fingers is equivalent to 4. So if you have 4, as you can see here po, you have a common node which is number 1. So that number 1, you can, when we design po, we have to make sure na yung transistor natin are all in the same node. If those node 1 is common for A and B, so you can interdigitate or share those nodes. Okay pa? So how do we do a good matching if we have this kind of example, this kind of schematic? So number 1 techniques is the A-B configuration. So this one is a good techniques to do the layout, but there's a better way to do it, is the it's the same, it should be ABBA. So ABBA, ABBA. So here on the left side you see it's AABB, AABB. So the one on the right is the best or the better option for us to get a good matching. So let's go on the next screen how or why those are the ABBA configuration is good matching. So here po is a simplification of the mismatch range if you have an ABBA configuration. Okay, so as you can see on the right side po, on where I'm pointing at, this, imagine if we have an XY axis and the process is linear. Okay, so the spread, so when manufacturing, or let's say TSMC, when they manufacture the chips, they're hoping to get a linear spread of the process. It doesn't happen in the actual fabrication, but at least we can see what is the reason why this ABBA mismatch configuration is the best or the better option to get a matching. Okay, so we have the X axis and we have the Y axis here. So imagine if we have an ABBA configuration. So let's say device A. So first device for A has a mismatch value of -2. So where is -2? Here. So here is a -2. We have one row, or one column, is it? Or one axis or one point is equivalent to 1. So the one on the left side is negative numbers, the one on the right side is a positive numbers. So A is -2, so we put -2 here, and the second device for A is what? +2 or +2. So the total mismatch of A is 0. Why? Because we have the value of -2 here and the value of +2. So if we add that, minus 2 plus 2 is equals to 0. So there's no mismatch. The range mismatch for there, device A is 0. Let's go to letter B, or device B. So here we have, for B we have minus 1, and for the positive B we have plus 1. So the total mismatch for B is same again, it's 0, because why? It's negative 1 plus 1. So we have a mismatch range for device B is equivalent to 0. So with the assumption that this is in a linear process model, or like going straight, so the mismatch range between A and B is equal to 0. So there's no mismatch due to process gradients. Okay, so that is why this configuration is the best or better approach to get a better matching for our devices. Okay, so there are also some techniques when you're doing layout, when at the end of the transistors, most in general, most skilled layout engineers, they add dummy transistors or dummy device at the end. Why? Because during the fabrication, imagine if you only have your actual device there and you don't have dummy at the end. So sometimes when the fabrication house or the fabrication company, when they manufacture the chip, when they etch the chip, the end part of that main part of the device, the gate or the polysilicon, you see that the pink or the red layer, sometimes they etch under etch. So we have, like in transistors, we have the dimensions which is width and the length. So when manufactured, this is a good, when the designer said, okay, I want a good matching for this device. So we have to make sure, as a skilled layout engineer, you have to add a dummy device at the end. So when they manufacture it, it will manufacture or process that particular edge of that device to be equal on all the devices inside of that, because it's seeing the same layers on all the edges. Okay, so that's why we have to make sure that if it's we want to have a good matching, we want to add dummy transistors there on the edge. Okay, so next is this one. As I mentioned last time on the last few slides, we have 3 companies that is like the foundries and the EDAs, or the electronic design automation. So Google partnered to one of the fabrication house, and they open up an open MPW shuttle program. So what is an open MPW? So MPW is a multi-project wafer design. So that means, so each company or each customer can join into a they can develop their own chip, and then they can submit their design, and then the fabrication house can fabricate it for free. So that's the program. So that's why it's an open MPW, but it's free because Google is paying for it. But the only catch is, because it's an open or open source program or license, you have to they will ask you to share all your design. So you have to open up your design to everyone who join on that program. Okay, so that's the catch. But nevertheless, it's free, because designing or making your own chips will cost you millions of dollars. So you don't want to design or to prove a prototype and then you want to spend millions of dollars. You don't want that. So for you to have your prototype or your ideas working, you can join the Open MPW Shuttle program. Okay, so next is the 3 emerging technologies today. So what are those 3 technologies? Number 1 is 5G. So 5G, as you can maybe in the Philippines or even here in Australia and all over the world, we have 5G already. So we have a 5G cell phone. We have the 5G tower already. So there's the infrastructure is there. So 5G is the next generation of communications. So it will be 1,000 times faster or 100 times faster than the 4G technology. So which company or startup design 5G technology? So one is Mobix Labs and Movandi. So these 2 companies I work with. So I worked for Movandi for 5 years, and I just moved to this new company, which is called Mobix Labs, and I'm now leading my team. So I'm as a layout manager. So I lead about 9 layout engineers, both here in Australia and in the US. So it's really a good experience. Okay, next is an Internet of Things, so IoT. So IoT, this is again, it's a wireless chip that is you can see if your TV is wireless now, that can connect to your Wi-Fi, even your fridge or your refrigerator or your washing machines. Everything is becoming smart. So that IoT is the one helping. That's the chip that helps to make it smart. Okay, so one of the startup company here in Australia is Morse Micro. Morse Micro, one of the founder is one of my friend. He's a really good engineers, and he is really getting they're getting a really good funding from investors. So Morse Micro, so search that on Google, so you can see what is Morse Micro and what are they doing, and they're really doing a really cool chip. And the next one is the artificial intelligence, so AI. So as you can see, those autonomous vehicle like Tesla or Google or even Facebook. So they have their own all these artificial intelligence happening. So Google, Amazon, and Microsoft, and all these big tech companies, they're developing AI. Okay, so that's the next generation. So those 3 are the 3 emerging technologies today. So I don't know what will happen in 5 or 10 years from now. Maybe our phone is not as big as what we are using now. Maybe our phones will be now implanted into our I don't know, in our brain or in our hands. So everything is possible. Okay, so the next one is these are some of the chips that I developed and I designed, and some of them are on the market. So one is the chip that I designed at Silana. So we designed a high-speed USB 2 isolator, and that you can see here, it's just a small chip. As you can see, it's just as big as one of my thumb on my finger or pointer finger. Okay, but you can see here po, I have it here with me. I don't know if you can see that, but that's the this is the chip that I have. Okay, and the next one is the one I designed at Movandi. So I'm the one leading the chip development for that. on the layout side. So as you can see here po, it's a 60 gigahertz 5G millimeter wave. So I think you're using 5G now on your phone. Maybe you have Samsung or Huawei or Oppo, so they have these 5G chips already. So but those 5G chips that is built in there is also a 5G, but they call it the sub 6 gigahertz. Okay, so those are the base line of 5G. So that means it can only run up to 6 gigahertz, but this one is a 60 gigahertz chip, and this will will change the aspects of 5G. So as you can see here po, I don't know if you can see, I don't know if I can make it big. So those tiny chips, you can see here there's a white and black area here. So that is one of the 60 gig chips that we've designed. Okay, and on this particular module or this board, it has 1 2 3 4 5 6 7 8 chips of the 60 gigahertz. And then behind that, as you can see, there's like an array of small dots here. Those are the 5G antennas. So you can imagine now, if you go and check the cell towers, you can see all those big vertical antennas. Those are for the older technologies, maybe 3Gs or 4G. But next time you'll see smaller antennas, smaller package chips here. So this 60 gigahertz is now available, and Movandi is now trialing it to the customers. Okay, so with that, I think that's all for my part. Thank you for listening. Hoping that you understand or you get something, even though if your background is not in engineering. And if you have any questions, please let me know po, and I can answer with the best of my ability. Okay, that's all for me, Professor Jane.
Okay, maraming salamat, Engineer Dennis. So medyo, at least ngayon naiintindihan ko na kung ano ibig sabihin ng 3G, 4G, and 5G. Kaya lang, sad to say, sir, baka sa sitwasyon ng Pilipinas, kahit na capable ang aming cellphone for 5G, ang internet namin ay hanggang 3G lang ang kayang tumakbo. Tama po ba?
Yes, sa ngayon, I think you're still using older technologies, but on the siguro dun sa mga like CBD or city or the main region, there are some few probably there are some few 5G antennas that's already installed, or maybe what's the big company in the Philippines? PLDT. Is it PLDT or Globe Telecoms?
Yes,
So
smart.
yeah,
Smart
or
LD.
Smart Globe, yeah. So I think they're trialing some of those 5G already. But yeah, just like what I said, they're using the sub 6 gigahertz of that frequency. They're not using the millimeter wave yet. So the millimeter wave starts from 24 gigahertz up to 60 gigahertz.
Okay, maraming salamat. At least medyo naintindihan ko na ang cellphone ko. Kahit pa paano. So, yun lang sir. Minsan kasi nakakapagtaka, di ba, na ang bilis-bilis ng cellphone nating umandar pag nasa abroad. Pero pag nandito sa Pilipinas, good luck. So, yung 4G, 3G, 4G, kahit na capable ang ating cellphone for 5G, 4G pa yan, pero kung ang internet natin nagkakaroon ng problema or ang location mismo natin, dun tayo talaga, yun yung magiging cause kung bakit or bumabagal ang internet. So, Guys, welcome ang mga, kung may mga tanong po tayo or may gusto kayong malaman tungkol kay Sir tungkol sa topic ni Sir Dennis, let me discuss first the rules for this alumni webinar. Okay? So please, when asking question, kindly introduce yourself with your name, course, year, and section. You may raise your hand on this Zoom webinar, or you can post your question on the comment section of our Facebook page. So please feel free to turn on your cameras when asking question, and you can also type out your question using the Zoom chat. Okay guys, meron po bang tanong tayo kay Sir Dennis? Welcome na po at pwede na po tayong magtanong kay Sir, at you can interact with our speaker. Alam ko po marami pong engineering or ECE tayong nakikinig ngayon.
Yes po, feel free to ask questions po. Anything under the sun.
Anything under the sun daw, sir. Sir, may message si Engineer Mirna Cabrera. Thank you, Engineer Luzon. The ECE department is so proud of you. More blessings, stay healthy and happy. Okay,
thank you po, Ma'am
according
Cabrera.
naman, sir, from Mr. Manuel, Mr. Angelo Noel Manuel, he is from National Teacher College. My insight, I will use this presentation of your guest speaker this morning in my personal growth to my friends, family, and classmates. Then Angelo Noel H. Manuel, NTC. Congratulations to the organizer of the successful webinar this morning. I hope you have a future webinar soon. So guys, pwede po tayo magtanong kay Sir. So may tanong po ba tayo?
Pwede ko kayo magtanong.
Marami, sir, tayong
Kahit tanong nyo, ha? Huwag lang kayong mangungutang. I'm just kidding.
Opo. Ayun, wait lang. Tingnan natin. Sir, tingnan natin sa ating Facebook page kung may nagtanong. So, ayun. Sir, we do have a message from Engineer Eduardo Tamayo of ECE Department. One of the reason daw po kung bakit nag-i-inflate ang mga GPUs ay due to shortage of semicon. Ano pong ginagawa ng mga big companies to anticipate the problem? Sir Eduardo Tamayo, gusto niyo pong mag-open ng camera so you can interact with our speaker, sir?
Okay.
Hindi daw po siya engineers. Sir Edward?
Sir Edward. Okay.
Okay, you can open your camera po.
That's a really good question. Kasi that's true. One of the big problems nowadays of the technology or semiconductor technology is the chip shortage. Okay? So just like I said in the presentation, like TSMC po, they're investing $100 billion over the next 3 years. So nagtatayo po sila ng at least maybe 3 or 4 or maybe 5 fabrication or manufacturing plant in the US. So that is just that's investment alone is just for TSMC. So $100 billion. So same thing po, Intel is also building or catching up sa TSMC. So they're investing $20 billion over 3 years. So they're also putting a fabrication or manufacturing house or plant in the US next to TSMC. So imagine those investments. So over 3 years, so hopefully we'll catch up with the shortage, and the prices of the technology or the chip will become back to normal. Okay.
Okay, thank you, Sir Eduardo. Sir, may question po. Ma'am Mirna, pwede ka po mag-open ng camera so you can interact with our speaker po. Engineer Mirna. Pwede na po kayo mag-unmute. Ma'am? Okay, sir, may question. Okay. Sir, may question si Engineer Mirna Cabrera. Is the IC used for smart devices available locally? Wala daw po siyang camera.
Okay, okay po. Oy, thank you po, Ma'am Cabrera. Nice to see you po, or nice to see your message po. Thank you. Yes, I think locally, I don't know, when you say po locally, is it like the Philippine market? So when we say locally po, I think I didn't see any big communities of local startups in the Philippines. But there are some like big companies in the Philippines, like like ROM LSI, the first company po na pinasukan ko after graduation from PUP. So ROM LSI po is still active in the Philippines. They still have a few hundred layout engineers based in, I think they're still in Pasig po, or in close to SM. So they have a big office there po. So when you say po smart smart devices available locally, so I think it's there's no availability of smart chip yet, but we do have a lot of talents or engineers in semiconductors that is based locally po. So ROM LSI is one po, ROM LSI Design Philippines. So it's a Japanese company, and and they have office here in the Philippines. I think that's hopefully po, ma'am, I answer your question.
Yes, sir. Plano daw po niya kasing mag-develop ng smart device.
Oh,
So,
okay po. Yeah, I think
looking forward for that yan, ma'am.
That's good po. I think it's a good start. So make sure that we have the eagerness po to develop or make a new technology. So that's why, just like what I said let me share po again my screen. I show you the...
Yes, sir.
Okay, let me share po, ha. So I think the one, so this one po, see Open MPW. I think this is a start po, Ma'am Cabrera, and to all engineering, those who have engineering background. You can you can join, and I can help po in the best of my ability. We can develop, or you can try putting a design, joining an open MPW that is free. But even the tools that they're using po, pati po yung mga software na ginagamit is open source. So that means it's available for free. So there's no holds bar. But the thing is, we have to learn the tools. So I haven't tried their tools because it's not used by main companies. But if we go through this open MPW, just check the website po on the top and read about it. And if you're interested po, especially the ECE department or computer engineering department, you can start building ideas, schematic designs, or what you want to design. And then if we're going to, maybe there's a possibility that we can join this program po, and this is a good exposure for the engineering students for the PUP as well. Okay po.
Yes, sir. Maraming salamat. Sir, tumatanggap daw po ba sila ng oldies doon? Baka daw kasi may age limit na, sabi ni Ma'am Mirna.
It's open to all po. It's open to all. There's no age limit. It's just all ideas po. If you have ideas, may it be a small ideas or big ideas, everyone is open.
Opo. Sir, may tanong, Sir Alexis or Miss Alexis? Can you okay, from BSCPE PUP, Alexis, Alexis Ryan, Mr. Alexis Ryan, you can open your camera and you can ask your question to Sir Dennis. Sir Alexis, or you want me to read out your question na lang po? Pwede ka na po. Pwede ka na po mag-unmute, sir, and mag-open ng camera. Sir Alexis. Okay. I read na lang daw, sir. Sir, may question siya. Ano daw po ba yung maibibigay niyong advice sa mga future engineer, especially for the ECE and CPS student na gustong maging layout engineer in terms of interest and skills? So
Okay.
that's a nice one question, sir.
That's a good question po. Yeah, especially those ECE students, demanding kami dyan. So after graduation, ano kaya gusto ko is either semiconductor or telecoms. So those are the two areas na pwede nating pasukan, So napunta ako sa semiconductor, which is doing IC layout. So ang suggest ko, reach out dun sa ROM LSI, and also there's another company, I think what is that company? I can't remember, but I have connection with them. I have contacts with those companies. So if you need recommendations or contacts, I can connect po. So my advice is for newly grads or graduating as ECE, okay? So yeah, you have to pick kung anong gusto niyo, kung semiconductor ba kayo pupunta or sa telecommunications, just like PLDT or Globe Telecoms. Because that's the technology that will fit our course. So yes, so gaya ng yung presentation, I'll share the presentation to Ma'am Professor Jane, so she can share it to everyone. And if you want to learn something as well, there's a lot of tutorials online. You can see like IC layout. If you search on YouTube or Google, just search that. That's the best way of learning things. Kasi I know it's hard to learn if you don't have the tools, di ba? So, but if someone is guiding you, so first, just search Google or YouTube. Search IC layout tutorial, and you'll see a lot of answers or links for that.
Okay, maraming salamat, Sir Engineer, Engineer Dennis and Sir Alexis. Maraming salamat sa question, and I hope nasagot po ni Sir Dennis yung question nyo. So maraming salamat daw, sir. Thank you po, sir. Okay, may tanong pa po ba tayo? So countdown po tayo, ha? And in 3 po, kung may magpa-pop in pa, i-ask po natin kay sir. Kung wala na po, I hope na makakapagpahinga na si sir ngayon. Kasi I know na, sir, what time is it now there? Anong oras sir ngayon?
Almost 2 o'clock in the afternoon, 2 p.m. 1:55.
2 p.m. So anong season sir nila ngayon?
Summer na ngayon dito.
Iba seasons nila ngayon.
Summer kami ngayon dito.
Summer. Apo. Kasi sa ibang park, di ba sir, ngayon is almost, ano na sila, winter na po
Winter,
sila.
winter,
Autumn na po
yes.
Autumn na po. Yes po. Sa inyo is summer. Opposite po kasi normally for Australia.
Yes.
Okay? So, kung wala, ayan, sir, may humabol. Si Mr. Carlo Padinar, ECE. Okay, Sir Carlo, gusto niyo po bang ikaw ang magtanong ng question niyo kay sir? Okay, wala daw siyang mic. Hello po, sir. Good morning po. Question lang po. Among the 3 EDA or electronic design automation that's you mentioned, ano po yung pagkakaiba nila at ano po yung madalas gamitin ng industry? Yun, sir, yung question niya.
Okay, that's a good question. Ano? So, those doon sa top 3 EDA companies na ginagamit ng majority ng mga semiconductor companies, yung Cadence. Ano? So, Cadence, they use their software mainly kasi sila yung majority na ginagamit ng mga companies. So, in a way, mahal yung license ng any EDA companies. So for Cadence, at least you have to spend what $1 million every year just to get the full license for for Cadence. So siya yung number 1, Cadence. So there sila ang number 1 sa layout and schematic design. Okay? But most verification like LVS or layout versus schematic or DRC, which is the design rule checks, most companies are using Mentor. Okay? So they're using Mentor caliber. So those are the difference. So Mentor is nakuha nila yung market share ng verification, but Cadence nakuha nila yung market share ng schematic and layout. Synopsys, ang kanilang advantage is more on digital side. So like yung place and route automation. So yun ang difference nila, yung tatlo. Okay?
I hope, Carlo, nasagot na Sir Dennis yung question mo. So, ayan. Thank you, sir, daw po. Thank you raw po, sir. Okay. Let me acknowledge the presence of the Dean of the College of Engineering, Engineer Remedios Ado, the Chairperson of the Electronics and Communication Engineering, Sir Joffrey Salvador. Nandito po sila, sir, sa Zoom. Present po yung Chairperson at Dean ng College of Engineering and Chairperson as well. So, okay, the Zoom link for the evaluation form for this webinar is posted on our Zoom chat and the comment section of the Facebook page. So, sir, without any further ado, siguro wala na po tayong question. Let me introduce po for the awarding of the certificate, Engineer Florinda H. Oquindo, the Director of the Alumni Relation and Career Development Office and Assistant to the Vice President for Students Affairs and Services, Engineer Florinda H. Oquindo. Okay, can you give a virtual clap to Engineer Oquindo?
Hi, good morning. Good morning, sir.
Good morning po, ma'am.
Good morning po. Regards po kay Sir Luzon.
Ay, makakarating po.
Yes, sir. Sir, in behalf of President Muhi, we would like to express our sincerest gratitude for being with us today. Alam po namin na napaka-busy ninyo, but despite your schedule, ay napagbigyan niyo po itong aming project na ito para sa atin pong mga scholar ng bayan. So to award this certificate, allow me to read the citation. Office of the Vice President for Student Affairs and Services, Alumni Relations and Career Development Office. This certificate of appreciation is given to Engineer Dennis Luzon, of Greater Sydney area, Australia. In grateful acknowledgement of his engagement and insightful academic contribution as resource speaker, imparting unparalleled knowledge and expertise on RFIC and mixed signal layout technique. During the webinar series with the title Balik Sintang Paaralan, the PUP Alumni Webinar Series, held on October 22, 2021 via Zoom and Facebook live stream. Signed, yours truly, Director, Alumni Relations, Career Development Office, and Dr. Sinaida R. Sarmiento, Vice President for Student Affairs and Services. Sir, thank you so much po.
Thank you din po, ma'am. Thank you po.
Guys, can you give a virtual clap to Sir Dennis, to Engineer Dennis, or a heart? Okay, so dumadami, sir. Oh, 9, 10, 16, 11, 13. Okay. So, maraming salamat. I know that the College of Engineering, Polytechnic University of the Philippines is so proud of you as a successful alumni of the College of Engineering. So in behalf of the Alumni Relation and Career Development Office, Polytechnic University of the Philippines, it is my pleasure and thank you for taking your time off and attending this webinar. And Sir Dennis, I hope to see you soon kung umuwi ka po sa Pilipinas. Punta ka po sa PUP, drop by to our office. So at least kahit pa paano po, meron kayong konting tour kung may pinagbago na ang PUP. So,
yes
I
po.
hope to see you soon after pandemic, sir.
Yeah, we will do that po when we are given a chance to visit the Philippines again. Okay po. Namimiss ko na yung yung puresa. Yeah.
Yes, sir. Opo, kala ko namimiss nyo na rin yung yung mga ano ba yun, gising-gising,
Gising-gising, oo.
anlilugaw.
Tsaka yung
Tama ba,
kwek-kwek.
sir?
Oo, yung kwek-kwek. Namimiss ko na yung kwek-kwek.
Sir, may mga bago na tayo. Meron na tayong, yung putlong pewa ni Bergie.
Putlong hotdog.
May
Oo,
pewa na
tama.
si Bergie. Yes, sir.
I remember that
Nung
kasi
mga times na
nung panahon namin naghahati-hati kami. I think 20 kami sa isang putlong
Actually, sir, naranasan ko din yon. Pero hindi naman nung time namin, hindi pa naman kami, hindi naman 20. Tatlo. Kasi ang laki talaga ng putlong. Imagine that time. Tama ba, sir?
Tama yun. Oo.
Pero, yes. PUP is proud of making people na, alam mo yung, hindi tayo mayaman, pero hindi tayo nagsimulang mayaman, pero kinakaya natin yung sarili natin and ginagawa nating proud ang PUP ginagawa nating proud ang PUP sa specialization na pili natin.
Yeah,
Tama ba, sir?
That's true. Especially, actually, yung wife ko is a PUP alumni as well. She's graduated with BS Computer Engineering, si Engineer Eleanor Luzon. So I think one day I'll convince her to do the webinar.
Yes, sir.
Yeah.
Yes, sir. Baka, sir, pag uwi nyo, I guess will be kukontakin din po namin kayo for a testimonial, or you'll also be invited, or invite po namin kayo to attend the PUP Alumni Homecoming this December 10. Opo.
Okay. Yeah.
By the way, let me take this opportunity to invite you all para po umattend ng Alumni Homecoming this coming December 10, 3 p.m. The link for the alumni homecoming is posted at the PUP official Facebook page. Okay, so yung gusto mag-register, and by the way, it is free to all. Okay po? So hindi man po tayo magkita-kita in person, magkikita-kita naman po tayo virtually. Okay? So again sir, maraming salamat at I hope I hope na makasama namin kayo or pagkatapos this pandemic, si engineer or si Mrs. Luzon naman yung mag-grace ng time sa amin for attending this alumni webinar. Again, maraming salamat and our apologies kung meron po kaming connection problem. Thank you and
Thank you.
again, thank you po. And again, this is Professor Jane S. Pulma from the Alumni Relation and Career Development Office. Arigato gozaimashita, signing off.
Thank you po. Bye, everyone.
Thank you,
Salamat
sir.
po.
Goodbye. Goodbye, sir. Thank you, sir.
Thank you.
Thank you po.